This is the big one. This is balancing simple equations. I've also made a couple of videos about how we make simple equations and about why it's important to balance simple equations. So I suggest you watch those before watching this. For this one, I'm just going to focus on the actual method of how we get these simple equations balanced. A lot of people don't like this and probably make it into something that's actually a bit worse than it is. If you've got a bit of patience, you will be able to do this no problem. You just have to follow the method through quite carefully. First of all, first step, we're going to write each type of atom under the arrow. The arrow, remember, is the point that separates the things we start with, the reactants, and the things we finish with, the products. So it's really important. Under the arrow, we're going to write down each type of atom. So we've got some magnesium atoms in there, we've got some hydrogen atoms in there, and we've got some chlorine atoms in there for this reaction. Okay, next I'm going to write the total number for each type of atom in the reactants and in the products. So starting with magnesium, in the reactants we've got 1, because remember no number means 1. And in the products we've got 1. For hydrogen, in the reactants we've got 1. And in the products we've got 2. For chlorine, in the reactants we've got 1. In the products we've got 2. Okay, so it's not balanced, clearly. We need to do the next step, which is to change the numbers of each by putting big numbers in front. Okay, that's fine. It says that we're going to keep doing this until balanced, and if any atom appears as an element by itself, to do this last. Well, magnesium appears by itself, but that's already balanced, so I won't worry about that. Hydrogen also appears by itself as an element, so I'll do that one last. Let's do chlorine first. I've got 2 chlorine atoms here, but only 1 here. So I'm going to put a big 2 in front here. Remember, I can't put a little 2 there. That would change the formula of it. I've got to put big numbers in front. So that means that there are now 2 times the 1. So there's now 2 chlorine atoms. But that has also changed the hydrogen. There's now 2 hydrogen atoms as well on this side. As it happens, that's a really good thing because this equation is now balanced. 1 magnesium to 1 magnesium, 2 hydrogens to 2 hydrogens, 2 chlorine atoms to 2 chlorine atoms. So that is now done. That was quite an easy one. Okay, I'm going to do another example then. This is going to be a slightly trickier one. This reaction is ethanol burning in oxygen to make carbon dioxide and water. If you set fire to the brandy on a Christmas pudding, this is the reaction that's happening. So, same again, under the arrow, there's carbon atoms, there's hydrogen atoms, and there's oxygen atoms in this reaction, just those ones. So I'll put those there. I'm going to write the total number for each in the reactants and products. So starting with carbon, I've got 2 carbon atoms in the reactants and 1 in the products. I've got 6 hydrogen atoms in the reactants and 2 in the products. And oxygen, just watch out because it appears twice here. Got 1, 2, 3 in total in the reactants and 1, 2, 3 in total in the product. Okay, now I'm going to change the numbers and I'm going to finish with one that appears by itself as an element. Oxygen in this reaction appears by itself as an element, so I'm going to finish with that. I'm going to do that one last. So let's do carbon. Got 2 on this side and 1 on this side. So I'm going to put a 2 there. So there's now 2 carbon atoms, but that's also changed the oxygen atoms. So now in total for oxygen, I've got 2 times 2, which is 4, and the 1 there. So I've got a total of 5 oxygen atoms now. Okay, let's move on to do hydrogen next. I've got 6 hydrogen atoms here, and I've got 2 there. So therefore, I need to times this by 3 to get up to the 6. If I put a 3 there, I've now got 6, 3 times 2. That has also changed the oxygen though, because there's oxygen attached there as well. So now in total for oxygen, I've got the 4 there, and I've got the 3 here, so I've got a total of 7 oxygen atoms. So I've just got to finish with doing the oxygen, and this is why I finished with oxygen, because it appears by itself as an element. It's easy now to finish it off. Remember, I've got 1 oxygen here, and I don't want to add any numbers here because that would change the carbon and hydrogen. So I'm going to leave that 1 there, and that means to get up to 7 I need 6 from this. So what do I times by 2 to get 6? 3. So if I do that, I've now got a total of 7 oxygen atoms. So it's 6 there and 1 there. So that reaction is now balanced. It was slightly more complex. It took a few more steps, but we got there just by following the rules. There's a couple more that I have shown in a different video, so I'll just quickly go through those ones now. I'll go through number 4 using that method, and I'll just talk through the others. So just so you've got one more example of going through the method. In this reaction, we've got calcium atoms, carbon atoms, oxygen atoms, hydrogen atoms, and chlorine atoms. So a bit more going on this time. Okay, so calcium, we've got 1 atom there. We've got 1 atom there. Carbon, I've got 1 atom there and 1 atom there. Oxygen, 3 atoms there and 1, 2, 3 atoms there. Hydrogen, 1 atom there and 2 atoms there. And chlorine, I've got 1 atom there and 2 atoms there. So it should be quite straightforward, this one, because it's nearly balanced already. I just need to change the hydrogen and the chlorine. I can do them both by putting a 2 in front of that. And that means that there's now 2 hydrogen atoms on that side and 2 chlorine atoms on that side. So that is now balanced just by putting a 2 there. Okay, the other reactions that I've talked about in other videos, this one's burning methane. It's what happens in a Bunsen burner. I'm just going to talk you through how you can see it. So I'll do oxygen last because it appears by itself. So I'll start off with carbon. 1 carbon on this side, 1 on that side. So that's sorted. Hydrogen, I've got 4 hydrogens on this side and 2 on this side. So if I put a 2 in front there, there's now 4 hydrogens on this side and 2 times 2, 4 hydrogen atoms on this side. So hydrogen's good. Oxygen I said I'd do last. 2 oxygen atoms on this side and 1, 2, 3, 4 oxygen atoms on this side. So to get it up to 4 on this side, I'm going to put a 2 in front there. So there's now 2 times 2, which is 4 oxygen atoms here, and 2 add 2, so 4 oxygen atoms there. This is calcium carbonate breaking down to make calcium oxide and carbon dioxide. 1 calcium atom goes to 1 calcium atom, that's good. 1 carbon atom goes to 1 carbon atom, that's good. 3 oxygen atoms go to 1, 2, 3 oxygen atoms. That one is already balanced. I didn't need to do anything to it. So not all equations need you to balance them. There are a few that are already balanced. Last one, which I do talk about on a different video. Hydrogen burning in oxygen to make water. It doesn't matter which one I do because both hydrogen and oxygen atoms appear by themselves as elements. So I'll just do hydrogen first. 2 hydrogens to 2 hydrogens, that's good. 2 oxygens to 1 oxygen. So I need to put a 2 in front of this whole thing. And that means there's now 2 oxygen atoms because 2 times 1. So oxygen is now good, but I've changed hydrogen again. So I've now got 4 hydrogen atoms here, but only 2 here. So I need to put a 2 in front here, and that means there's now 2 times 2, 4 hydrogen atoms there. So those ones I've just worked through just by looking at it and talking you through. But whenever you've got to do this, always follow through that method where you write down the different atoms and you keep track underneath.